Hi, Holly. I'm making one of our IT person as the panelist. I hope that's okay.
Yep, that's fine. Yep, thank you.
Yeah.
So we give it just till after just gone the hour, shall we, before starting? Give people time to join.
Yep, great.
Holly, before we start, can you give access? Can you give access to the to our IT person to record the session locally? Is that possible?
Yep, we've just arranged that now, so that should be working now.
Yeah. Yes, perfect. Thank you. I think, Chris, we can start.
Yeah, okay. Great. Thank you. Well, hello and welcome to this Delta Dialogue event organised jointly by the Living Deltas Hub and our partners at this year's Gabeshina Conference. I'm Dr. Chris Hackney, a research fellow at Newcastle University, and I'll be moderating today's discussion. Today's event is the final instalment of our Delta Dialogue series. Through these dialogues that have been organised by the Living Deltas Hub, we've sought to promote interdisciplinary and international dialogue on crucial sustainability challenges that affect the world's deltas. Over the course of 6 dialogues, we've brought together speakers from different sectors and contexts to share their experience and to reflect upon the complex socio-ecological challenges that face deltas around the world. The aim being to strengthen partnerships in delta research, governance and policy at a regional and a global scale. These past events have covered everything from locally led adaptation practices, intergenerational solidarity for addressing climate changes, and the role of nature-based solutions in promoting delta sustainability. For today's event, I'm delighted to welcome 4 panelists who will be discussing how we can develop and use a range of different tools to enhance adaptive capacity within delta environments. We'll hear from our speakers about how numerical models can be used to understand the links between the physical and social worlds, how future developments in these numerical modeling tools are working to incorporate more arts-based disciplines to better understand how humans interact with their environment. And we'll also hear from some research that's been done actually utilizing those more arts and cultural-based tools to understand the responses and perceptions of climate change and environmental change in delta systems. I'm joined on the panel today by Professor Craig Hutton, who's a Professor of Sustainability Science at the University of Southampton. Alongside Craig, we have Dr. Hui Li, who's a Senior Researcher and Lecturer from the Central Institute of Natural Resources and Environmental Studies at Vietnam National University in Hanoi. We're also joined by Dr. Mashfiqus Salihin, who's Professor of Hydrology and Water Resources Management at the Institute of Water and Flood Management at Bangladesh University of Engineering and Technology. And our final panelist is Mr. Hoyang Kin, a PhD candidate at Loughborough University, who's a member of the Living Deltas Hub with us. We've asked each of our speakers to prepare a 7 to 10 minute presentation discussing the key themes of today's dialogue. We're going to hear all those presentations back to back, and then following that, we'll have an open panel discussion, question and answer session with our attendees online today. I'd invite all those people who are watching along online to put any questions you might have to our speakers around their presentations or the themes that are being addressed today more generally in the Q&A box, which can be found on the bottom, along the bottom kind of panel on the Zoom window. We'll be monitoring that as the discussions progress, and we'll raise those at the end in those in that big panel discussion. And we'll hope to get through as many of those questions as we can once we've heard all of our speakers. Without too much more ado, I think we'll move on to the first of our speakers in today's session, and that's Professor Craig Hutton from the University of Southampton. Craig has worked in sustainable development for about 25 years, and the majority of these he's been based at the University of Southampton. He's focused on sustainable management, deltaic and large river environments, community level adaptation, and the development in the light of environmental change. And he's going to give us a talk today around the use of tools and methods to address some of those questions. So Craig, pass over to you.
Great. Can I just check you can hear and you can see my screen?
Yes, I can. Yes.
Great. Okay. Thank you. Thank you for that, Chris. So today I wanted perhaps to set the scene a little bit around thinking about sustainability. And of course, adaptive capacity being a feature that sits in the broader domain of sustainability generally. And I wanted to, I suppose, discuss and advocate the use of tools and methods that consider the key points around sustainability. So I thought I would briefly talk about some of the approaches we've taken on deltas, particularly on delta systems, and to see how they sit with the audience. I mean, what is sustainability? Well, it seems perhaps that's a silly question in some ways. We think we all believe we understand that, but it is extremely important to think about it as being a function of not just the environment. I mean, it starts with some early statements around, say, the Brundtland report. Brundtland was a Norwegian prime minister in the 80s and was one of the first people to set up a sort of commission, was asked to set up a commission to think about what sustainability meant, and came up with a statement there. Natural capital should not decline through time, was another early statement that is sort of a vanguard of sustainability. And sustainability should, in fact, improve the quality of human life whilst within the carrying capacity of supporting ecosystems. So it should be a dynamic approach. We see in the 60s some of the global systems thinking, things like actually the Apollo missions, where we see images of the Earth, people beginning to think of holistic systems, and our adaptive responses need to be holistic. Engineers begin to think in the early 80s around soft responses as opposed to hard responses. Can we, for example, instead of building large defensive walls, can we be using green defense such as mangroves, or could we allow rivers, wetlands to flood into instead of trying to build levees in these systems? So when we think of our adaptive responses, can we think outside of just engineering ones? That's something we should be thinking about there. The Brundtland report comes out, and that takes some time before politicians begin to adopt it. And even now, whilst it's very popular, it's still fighting its way into political thinking. So when we think about sustainability, and indeed how we might think about adaptive responses that are sustainable, we must think about society, environment, and economy, not just environment. So we need to think about how these three, not only that we have these three, but how these three integrate. How do they interact with each other before we can truly call something a sustainable response? And when we think of our adaptation capacities, we need to be thinking about these three domains. Of course, you'll see it in many different ways. It occurs, it becomes more and more complex. Sometimes it becomes extremely complex, as complex as we want it to. But within that, we must be thinking about these three key domains, sometimes called prosperity, planet, and people. And there are various iterations of it, but keeping in mind this central component of the integration of these three domains. So what tools can we use that help us think about this? Well, there are many tools. The adaptive capacity we are talking about, of course, comes from the risk framework, where we can understand that risk is a function of the hazard, the exposure to that hazard, and the nature of the population, the vulnerability of the populations that are exposed. And sometimes we can assess those through, for example, the sustainable livelihood capitals. This is just to give one example where we've got financial capital, something that everyone is aware of, credit, insurance, money. We also have physical capitals, and we can assess populations and perhaps communities where we're thinking about adaptive capacity. We need to understand not only their income or financial capital, we need to understand what assets, access to roads, etc. But let's also think about social capacity, networks, community, institutional organizations. These are sometimes called the capital of the poor, the things that perhaps on occasion help to substitute for low financial capital. Natural capital, so perhaps our ecosystem services can be thought of as natural capital, and human capital, skills, knowledge, health, training, things that describe the individual. So we should be thinking about, when we think about adaptive capacity, what are the frameworks for assessing the individuals who might be conducting that adaptation processes, and also assessing the capacities more broadly than just financially. Other tools we might think about when assessing true sustainable responses more generally are things like the causal loop diagram approaches, where conceptually we can think about how elements of the economy, society, and environment, we actually begin to map out how they might interact with each other. This is just a nice simple example from passenger transport, but it applies to any aspect we look at. And when we actually model these, we generate models that derive from these, and we've done that on a number of deltas. We can begin to run these as systems and think about thresholds before changes occur. So it's non-linear responses, feedback loops, self-fulfilling feedback loops, trade-offs, because, you know, it may be that something you do for the economy can have a negative impact on the environment and so on. So, and probably is likely to. And we can think about scenarios, planning scenarios of the future for this. I mean, here is one that we did run. Salahim will be aware of this as a small part of a very large systems approach on the Delta we carried out for a project called ESPA, Ecosystem Services for Poverty Alleviation. And this was one small part of that, looking at the Bangladesh Delta front, where we thought about we modeled population and population dynamics. We looked at environment of crops and growing crops and environmental ecosystem services, and we looked at the economy, and we combined these into a system model for ultimately understanding welfare of populations. But this starts with a conceptual model, and this is the kind of thing that I think we could be looking at when doing adaptive capacity. Can we use these sorts of tools? And finally, one of the tools that we use a lot, and this is on the Mekong Delta, is then thinking about plausible future states. If you want to understand adaptive capacity, I mean, this is for land use management on the Delta in Vietnam. But if we want to understand adaptive capacity, perhaps we need to think about plausible future states. How will different choices around adaptive capacity actually play out into future worlds, if you like, plausible futures, and how, and these letters and numbers, D120, D139, these are policies that we can also map out onto these processes. And this is something I've been working a lot on. How do we generate generate plausible future states based on choices that we have to make? And we could certainly do that around adaptive capacity. But these are sustainability tools that I think could help feed in to that approach. Okay, I'll leave it at that. Thank you.
Great, thank you very much, Craig. That was a really nice overview of the kind of frameworks that have been applied in some of your previous work to address these issues. And I think there's a really nice link there to our next speaker, who's Dr. Hui Li, around the need for those choices and that kind of human input into these statistical, mathematical model frameworks that might be used. As I've said, we're going to go sequentially with our speakers. So if you have questions, please do add them to the Q&A box, and we'll come back to those for Craig at the end. So our next speaker is Dr. Hui Li from CRES at the Vietnam National University. Dr. Li received her MA in Urban and Environmental Policy at Tufts University and her PhD in Agriculture and Rural Development at the Institute of Social Studies in the Netherlands. From February to August 2012, she was a Fulbright Scholar at the Earth Institute in Columbia. And then from October to November 2016, she was a visiting scholar at York University in Canada before moving back to Hanoi. And Dr. Li is going to give us a bit of an overview into some of those human aspects that feed into these frameworks, and in particularly a youth angle on how they're adapting to climate changes in Vietnam. So, Hui, over to you.
Yeah, thanks, Chris. Hello. I would like to present to you a project that we are still working on for the second phase and the results of the project. And in this project, we would like to combine science and art together to tackle a very important issue, which is climate change challenges in Vietnam. And for this project, we focus on youth because we think that they are the agent of change, and therefore they can contribute greatly to climate change adaptation. And I'm going to present it now. All right. So in this project, we focus on the Red River begins from China. So it enters to Vietnam. Here is Lao Cai province, where the river enters to Vietnam in Lao Cai, and it flows mainly through some provinces here, including Yên Bái, Phú Thọ, Vĩnh Phúc, Hà Nội, Hà Nam, Thái Bình, and then it goes all the way down to the estuary area here in Nam Định province. So in this project, we focus on the Lao Cai, that is the upstream, where the mountainous area, and then where a lot of ethnic minority people are living, and then in Phú Thọ, the downstream of the river, where the land is a little bit flat, and some districts are concentrated by the ethnic minority people. And then finally, in the estuary here, we focus on Nam Định province, where the majority of Vietnamese people, we call the King people, reside. And then in this area is a very rich Vietnamese cultural identity. So why we focus on the Red River catchment? Because in this area, it is witnessing severe impacts of natural disasters and climate change. The government and policy makers and local people of Vietnam are facing challenges related to disasters and climate change, and definitely indigenous knowledge or traditional science plays a very important issue in sustainable development, environmental protection, and disaster reduction. And the role of young people in mitigating the impacts of climate change is increasingly being appreciated. So in this project, we have like 5 objectives. One of the objectives that we want to do is to provide scientific support for analyzing co-created data and build knowledges to enable youth-led solutions to localized climate-related issues, and develop and support an innovative youth-led partnership between the National Youth Union and then the Mekong youth engaging in social action to urgently respond to climate change emergency and the impact of hydrological extremes, and then to integrate and showcase creative local art-based outputs, for example, like through film, storytelling, singing, or other traditional performance or dramatic techniques that are inclusive, accessible, and useful in building. And finally, to develop conceptual understanding of and evidence on both the benefits and barriers of the youth-led collaborative initiatives in addressing climate change and co-developed action strategies. For this project, we have employed the a participatory action research approach and creative methods to focus on effective positive change. And for data collection, we focus on visual rather than verbal, emerging in group rather than individual interactions. We also employed PRA tools, for example, like a key informant interviews and focus group discussion. We also use ArcGIS Survey 123 and Flipgrid. So here's you can see that one of the scenes that we were in training the youth coming from the 3 provinces, how to use the key informant interviews technique to interview local people to get information from them, or how to conduct focus group discussion with the local people, so that based on the data that they collected, they can write stories. And for the project results, the youth told us different stories, and all of the stories were put in the story map. And here's the link to the story map. And then I'm going to let you know what kind of innovative ways that the youth used to tell us their stories. For example, this one, they used a drawing by hand, and that's the story about an old man, and he survived through the rainstorm, and then for him, it is an unforgettable story, and it's a very impressive, and everyone just really liked this story, and then they learned a lot from him. Now he's old already, and he told the younger generation, how to live, in a very environmental friendly way, so that they could just adapt to climate change effectively. And this one, you can see that here a local farmer, they harvested the rice, but this one is a saying like green at home is better than ripe in the field. So they had to harvest the rice before the storm came, so that they could save the rice at home. And it's better to get the rice green than just wait until it gets ripe, but the storm came and then they will lose everything. And this story, the youth used a video, and then this story about a boat port, and this one just told us about the sea level rise. You can see that the water just came up here, but when he was young, he never saw something like this. And this story also reflected by the flip grid. Can you see? When he was young, and then he became older, and then you can see the sea level rise. Yeah, so it is very effective way to tell the young people about the climate change. And this one about the local song, and then the teacher together with the students in her school singing a local song, and it's about the importance of mangrove forest and children's activities on protecting mangrove forest at Xuân Thủy National Park in the estuary of the Red River. And this one, they use a diagram, it's about the story, how people joined hands to overcome the floods. And this one, it shows all the key stakeholders and their responsibilities in response to climate change. You can see here just, children, students, workers, policymakers, women's union, everyone to join together, to tackle climate change. And for this one, it's about, it's like an animation on dam story. And then this one about the new hydropower dam. And then during the floods, they released huge columns of water that killed animals and even people downstream, and it wiped out all the people's properties. But after the floods, the people here that try to overcome the difficulties, by planting the forest trees or, growing tea to help greening the hills and increasing income, and bamboo was also planted along the both sides of the stream to avoid soil erosion. And then in this way, they could just, have better life. And here for the final event of the project, we organized an expert panel discussion, and those here the questions that we posed to the panelists. And one of the questions that we raised here, it was that how can the youth really make a difference to climate change, or what do we need to do to support young people, and how can this project like this tackle climate change? And then in the panel, we invited policymakers, art workers, and also scientists and youth. So all came together, and then they think that it was a very good event for them to learn about climate change, and also to use innovative ways to tell the stories. And here is the water puppetry show, and you know that according to the different sources about the art of puppetry in Vietnam, the water puppetry started in 1121 during the king, Lý Nhân Tông, which is a long time back. And for international friends, Vietnamese water puppetry is a very unique and creative contribution preserved and maintained the oldest. And with the art of water puppetry, Vietnam has earned its rightful place in the history of the world art theater. So we decided to use this art to reflect, the stories told by the youth. And then here you can see the uniform of the youth, and here the local people, and here you can see the smoke, and then they burn the firecracker to make the smoke, and then the smoke here is the forest fire. So when the forest fire occurred due to climate change because of the drought, the youth came and then to help local people to stop the fire. And here you can see that, the singers, they were singing during the water puppetry, and then the audience, and many of them were children, they stayed from the beginning to the end of the show. The good thing about this show is that the normal water puppetry show, they tell stories, from the 1970s, and then they didn't have anyone to do research for them to bring in contemporary stories. But here we go. If we have them bring in these new stories, and everyone just really liked the stories. And these singers, they said that they learned a lot, about the show, and especially about climate change. They said that in the past, they heard people talk about that, but they didn't understand what it was until now when they played the show, and then they could understand climate change. That's it. Thank you.
All right. Thank you very much, Hui. It's absolutely fascinating to hear the types of knowledge and information that communities hold, and how we can use that and incorporate that into these other kind of systems models to better represent our understanding of these systems. Our next speaker is Mr. Hoyang Jin from Loughborough University. Hoyang is a PhD candidate at Loughborough, whose research concerns human activities during hazardous events. He's developing some simulation tools to predict individual and organizational behaviors using agent-based modeling. So I think he's going to provide a nice link between some of the human social behaviors that Hui has been discussing with some of the modeling frameworks that provide. So Hoyang, I'll pass over to you.
Thank you, Chris. Hello, everyone. Today, my topic is to introduce coupled human and natural system model, which is called chance model, with agent-based modeling for flood risk and flood impact assessment. Okay, at first, let me introduce our research background. As we know, the flooding is the most widespread natural hazard. It threatens people's lives and properties across the world. In recent years, the climate change has led to more frequent extreme rainfall and severe floods, and also the rapid urbanization and development in floodplains have seen the increased risk of flooding. As you can see in the right pictures and videos, there were heavy flood events in Europe and China in 2021, and also in last year, the heavy flood events affect the most areas of the whole Pakistan. So robust modeling tools and effective approaches are needed to assess and manage the flood risk. Actually, there is an obvious dynamic interaction between human activities and the flooding process, which can be described by chance modeling. The chance modeling could help our researchers to comprehensively observe and understand the motivations and the behaviors of urban residents and social organizations, and also understand the interaction between human behaviors and hydrological systems, and provide information for decision making. We proposed a new chance model because there is few chance models can consider and capture the detailed human flood interactions at a high spatial resolution across a city or region to inform holistic disaster risk management. As for the physical subsystem of our transmodal, we use a high-performance integrated hydrodynamic modeling system, which is called HiPIMS. It supports high-performance simulation for multiple processes, including flooding, landslide, debris flow, and sediment and pollutant transport. As we can see in the right, there are examples of the flooding process, landslide simulation, and the debris flow. HiPIMS is a flexible modeling framework, and it is widely applied in many countries such as the UK, China, and so on. And for the human subsystem in the transmodal, we use the agent-based modeling approach. We set specific features and behaviors rules for the agents and use them to simulate the decision makers in the flood event. As shown in the right picture, the agents can interact with the environment, such as the flooding water. And there are also interactions between different agents, for example, the communication between them. And our agent-based modeling part is based on the high-performance GPU architecture and distributed CPU architecture. And let me briefly introduce the application and test of our transmodal in the case studies. This case study simulates the 2015 storm Desmond flood in Eden catchment. We put in the terrain data, which is the DEM, land use data, and the radar rainfall data to drive the simulation. And in the agent-based modeling part, we simulated around 70,000 household agents. These household agents respond to the flood according to their conditions with probabilities. During a flood event, households have chances to observe the surrounding flood situations, and they can communicate with others. And also, some households will receive the flood warning during the event. And finally, we calculated the financial damage according to the water depth and the household response. And we designed 3 scenarios to explore different flood mitigation measures. The first scenario assumes that all households receive the flood warning because of the complete registration of flood warning system. And the scenario 2 assumes all households receive warning and they respond to the flooding immediately. And also the scenario 3 that the government provide up to 8 setbacks to the household to stop the flood water. And for the validation part in the baseline, the simulation results are consistent with the data in the government survey reports in terms of the number of flooded households and financial damage in the whole Eden catchment. And taking the central urban areas of Carlisle City as example, it can be seen that the number of flooded households and the financial damage have risen rapidly twice, which is in line with the 2 wave peaks of the flooding reported by the government. And comparing the scenarios, we got the results that if all households receive the early warning, the loss will be reduced by about 1.2 million pounds. And if all affected households take mitigation measures, the loss will be reduced by about 2.1 million pounds. This makes sense that if the government could get more households in the warning area to sign up for the flood warning system and keep the information up to date, then the flood damage will be reduced. And also, if the flood awareness of the residents is raised and the community can send people to help the households who cannot take flood protection measures such as community volunteers, then the flood damage will also be reduced. Here are some results for the setbacking scenario, but to save time, I will skip them now. If you are interested in them, we can discuss them later. And actually, during a flood event, human activities can affect the flooding process. For example, blocking the flooding with temporary defenses or moving water away. with mobile pumps. Recently, we are undertaking a case study considering the real-time impact of human activities on the flooding processes. We simulated the flood events in the urban areas of Calais City in the UK. In this simulation, we built technical staff agents for building temporary flood defenses. And as we can see in the picture, shows the red line is the location of the temporary defenses, and the agents will build every defense unit from the top to the bottom, and the terrain height of each grid will be raised up for 1 meter in real time after the corresponding unit is built. These are the simulation results of the flood event for 12 hours. We can compare these two results and find that the temporary flood defenses can indeed affect the flood process and effectively protect some target areas. Let me make a quick conclusion. At first, our new trans model can support high resolution simulation for coupled human and natural systems interactions across a large domain. It can also explore the role of different flood mitigation measures and provide a new tool to assess flood risk by taking into account the dynamic exposure and vulnerability. And finally, it is potential to explore different disaster risk management strategies to inform the emergent decision-making. For our future work, at first, we'd like to finish the two-way dynamic interaction to explore the real-time interventions. And then we plan to apply the chance model to the Canton City to assess compound flood risk, taking into account the dynamic household vulnerability and exposure, and explore the different risk mitigation measures. And finally, we are also finding a way to apply some AI technologies such as reinforcement learning to optimize the flood risk management strategies to support the decision making. That's all for my presentation. Thank you.
Great, thank you very much for that, Hoyang. I think it's absolutely fascinating the scope that these types of models open for incorporating some of the intergenerational knowledge that Hui was perhaps alluding to in terms of modeling our understanding and behaviors and how we can adapt to these sort of hazards. So thank you for that. Just a reminder that please do add questions for any of our speakers into the Q&A or chat boxes at the bottom. We'll come to those after our final speaker, who is Professor Salahin from Bangladesh University of Engineering and Technology. Get the initials the right way around there, Salahin. Salahin has been involved in a range of large international collaborative projects through the years, looking at Delta sustainability, ecosystem services for poverty alleviation with Professor Craig Hutton, who spoke earlier. Served in several government expert committees and institutional governing boards linked to the Bangladesh Water Board Development Joint Rivers Commission of Bangladesh and the Bangladesh Delta Plan 2100. And today he's going to kind of wrap up our speaker presentations for us, talking about how advances in modelling tools can aid delta adaptation and resilience. So Salahin, over to you.
Sorry, thank you, Chris. Just 1 second. You can see my slides, right?
Yes, that's all good.
Okay. Yes, so I'm going to talk about how modeling or advances in modeling tools can aid delta adaptation and resilience. So my presentation will be more thematic in nature rather than specific case study. So, and I'll be speaking mostly based on my experience and also the experiences of my colleagues in the last 10 to 12 years with modeling different processes, physical processes, and the interactions between physical and socioeconomic dimensions. So, depending on different type of modeling needs. So I'll be mostly focusing on fit for purpose modeling. So we are through showing some of our modeling experiences in the last decade. So first, Bangladesh is at the lower riparian of three large river basins, Ganges, Brahmaputra, and Meghna. So the country is is vulnerable just because of the lower. Because it's situated at the lower end of the three big basins, and it does receiving huge inflow and sediments from upstream. And so the physical vulnerability is there in terms of floods and also droughts, and then salinization in the coastal area, cyclonic cyclonic storm surges, waterlogging. So many problems, both in the non-coastal zone and in the coastal zone, and also basically climate change is going to reinforce most of the existing stresses and challenges. So it's not only the physical vulnerability that we are dealing with, we're also dealing with the socioeconomic vulnerability in terms of high population density, high prevalence of poverty, gender inequalities, poor access to education. So a lot of socioeconomic stresses, which make the risks even larger. So I'm sorry, what's happening? Sorry. So basically, what we are aiming for is a better Delta future through Delta strategic planning, sustainable and equitable livelihoods, sustainable management of Delta ecosystems, and better achievement of SDGs and stronger monitoring. And several policies and plans are in place. For example, Bangladesh Delta Plan 2100, climate change adaptation, the National Adaptation Plan, National Plan for Disaster Management for Disaster Risk Reduction, and very importantly, the Sustainable Development Goals. All the targets have been fixed, and in some of the indicators are in place to monitor the progress. So all these plans are, policies are to be implemented through the 5-year plans, which we have, every 5 years. So what models can do? So that is what we are talking about today. So basically, models help us to understand the complex reality and to simulate what will happen in the future and how we can prepare accordingly. So basically, models help us derive the guidance that we need to take strategic decisions in terms of disaster risk reduction or climate change adaptation, or even long-term Delta planning. So, but very importantly, how models work, and as we can understand, model cannot tell us everything. So there are certain limitations and uncertainties associated with model, and depending on the scale of issues that we are dealing with, so models models and their applications and their effectiveness will also vary. So models help us to understand the complexity of the biophysical processes and their interaction with different socioeconomic outcomes. It's very important to understand that it's not only the biophysical processes that are important and that shape our delta. So now that we are in the Anthropocene, so the human dimension plays a very big role. So it's important to link the biophysical environment with the ecosystem services that they impact on, and how they are translated to human welfare or livelihood and poverty outcomes. So it's a multi-scalar process that we are dealing with in the Delta. So there are some larger scale processes. For example, we are interested in quantifying climate change impacts, and anthropogenic scenarios, We want to forecast, do a good job in forecasting, take anticipatory actions. So we want to develop larger scale strategic interventions, protective measures, and we want to see the potential, investigate potentials of nature-based solutions, interventions for disaster risk reduction. But there are some, smaller scale processes, because we need to know when it comes to the implementation of locally led adaptations and sustainable development goals, like leaving no one behind. So the core principle, it's very important to know processes at the household or individual livelihood scale at least. So how different livelihoods are impacted differently, and how they respond differently, and how this has evolved in the last like 10, 15, 20, 50 years. So how different livelihoods or communities undertake different types of strategies at those scales. So these are important, very important implications for climate change adaptation and sustainable development goals. And one challenge is, of course, harmonization of these scales. So in our part of the Delta, so we use the hydrological basin scale hydrological model to understand the flow generation processes in the upstream 3 basins, using the basin scale hydrological model. And then we use a number of hydrodynamic and combination of hydrodynamic and hydrological models together with weather forecast models to do flood forecasting. And then we try to come up with impact-based forecasting and translate the flood warnings into the probable damages. So we realize that flash flood forecasting is still a very difficult task in Bangladesh beyond 1 day. So the lead time. So the results are still not very good. Perhaps it's more important to look at the pattern, or rather pattern of the flash floods, rather than looking at the magnitudes. So inundation, we can, using very high resolution hydrodynamic model, we can develop, we can understand the inundation patterns in the country, and so that's what we do. Very important information for impact assessment, damage assessment, and also examining different type of interventions. But then the coastal processes, the coastal delta. So we want to simulate flooding, storm surge, salinity integration, and morphological changes using hydrodynamic models. So we can do simulation for inundation. We can look at morphological changes, salinity, intrusion, cyclonic storm surge, or even waterlogging. So these are the important processes that biophysical processes that shape the vulnerability, physical vulnerability of the coastal zone. Using the models, we can simulate the baseline. We can also simulate the future, the scenarios. Some of the scenarios Craig showed in his presentation. So we can generate all the scenarios, and we can using the model, we can test the coastal protection systems, whether they are adequate to minimize the cyclonic risks. So whether there is a development dilemma, whether we should, why should we invest more, whether we should increase the height of the embankments, or rather spend more money on maintenance of the system. So the latter is the case. So that is what our understanding is. We can also analyze coastal afforestation, as a hybrid nature-based solution, which can increase the resilience of the coastal protection infrastructure. So, and that can go a long way, in increasing the resilience of the coastal social ecological system. So, as I said, it's very, it's an integrated system. We cannot really look at only the physical processes in isolation of the socioeconomic outcomes, because of the feedback or feedback systems that Craig mentioned. So we need an integrated assessment systems thinking. We need to take a social ecological systems approach, where we'll combine the complex physical, ecological, socioeconomic, institutional components and their relationships. So one example, Craig already showed example of one example, Delta Dynamic Integrated Emulator Model, Delta DM, that we had developed in ESPA Deltas with Southampton. So these kind of models are very, very useful. Basically, we translate the biophysical model results into ecosystem service, impacts, and then in turn, how they impact on poverty and livelihood outcomes. So, but then another important area to examine is the effectiveness or climate change adaptation needs. So we can use this kind of integrated framework. So like the one that we developed, dynamic adaptation model. So an integrated model framework where we basically look at the interaction of hazard, exposure, and vulnerability domains using a Bayesian, belief network. So we compute the adaptation deficiencies in response to the different hazard-specific risks. So this kind of tool are very useful while if we want to implement the national adaptation plan. So there are some opportunities. Other types of modeling tools, the examples would be the system dynamics model. So where so basically which represent the coupled socioeconomic and ecological system behavior through complex feedback loops. So we can assess water security risk and evaluate options or interventions for risk minimizations, and we can assess the synergies and trade-offs. So so those are very important in the context of implementing Bangladesh Delta Plan 2100. So we can similarly, we can use the system dynamics model in a stochastic optimization framework to investigate unequal distribution of water risks and adaptation benefits in the coastal delta. So I'm trying to give you some idea about the range of models that could be useful to help you understand processes at different scales. For example, when you come to the smaller scale processes, so the important things to look at would be livelihood diversity and resilience. So there is diversity within and across different social ecological systems, and there is a dependence of different livelihoods on ecosystem service. So how livelihoods are impacted differently and how they respond differently to specific hazards and disasters. So, and their coping and adaptation needs, and the gaps in their livelihood and water management practices. So these are very important. So as I mentioned before, in climate change adaptation and sustainable development goals. So agent-based models, so we already heard about this, are very useful. So these are like the emergent techniques or modeling tools that help us to understand the behavior, the interaction of different natural processes with human behavior, how different individual actors or actor groups behave, and interact with each other and with the environment, and through autonomous decision making. So we had some pilot applications in our coastal area, looked at mangrove social ecological systems, how different behavior of different livelihood groups are shaped by different rules established between different components of the system. And then finally, the coupled human and natural systems. So we can combine this agent-based model framework and Bayesian network to look at the livelihood-specific risk. So where risk would be a non-linear combination of hazard, vulnerability, and exposure. So, and we can assess the specific risk with respect to livelihood, vulnerability, and we can where we estimate the parameters using Bayesian network, and we use various agents which define different livelihoods with their specific livelihood-based criteria. So in sum, so there are different types of physical biophysical models and integrated assessment frameworks. So that are there, and that are also evolving. So new techniques are new tools and techniques are emerging. So that would be using those which we try to examine different processes at different scales across different social ecological systems. So I'll stop there. Sorry, I took a long time.
Great. Sorry, timed that well with me having a bit of a coughing fit. But thank you very much for that, Salihin. There's a great overview of all the work that you've been doing in Bangladesh and using these different types of tools. So firstly, thank you all to our speakers for your presentations. And now I'd like to kind of open this up to Q&A and a bit of a panel discussion between us. Please, for those attendees online, please do keep typing in your questions onto the Q&A box at the bottom, and I can moderate those and read them out to the panelists. We'll work our way through. We've had some questions come in, so I'll start coming out. The first of those was directed towards Craig. So Craig, in your presentation, the Venn diagram that you had in your presentation on economic development, social progress and environmental viability, I guess in your experience and in the deltas you've worked on, which option is the easiest to aim for? A fair world, a viable world, or a livable world? There's a philosophical question to get us.
Yeah, that is. I've been thinking about this. It's a tricky question because it depends who you are. I think it's fair to say, I mean, there's a sort of historical context to this in a way that, you know, like deltas, like most systems, really start quite economically. If we think in the Anthropocene, perhaps if we accept that being past 1950s, but we start to think about most of the big drivers have been economic. And then we definitely begin to see in the 70s, perhaps a much more social context. So we see this boundary between social and economic, a sort of fair world. People saying, well, okay, the economy's growing, but why are we only getting a fair world? I mean, why do we not have a fair world? I think we then have to have some sort of understanding of the fact that we have pressure for a livable world comes in much more recently. And what's interesting is it evolves sort of economic, a fair world, because you have social pressures applying about equity and growth and saying, you know, how does that, who's benefiting, trying to tackle poverty. You get a livable world is the pressure that is on now, in a way, to try to generate a viable, fair and livable world, which is sustainability. Now, I think so what is the easiest is, well, the easiest is an economic and social, because it's there and it's the doors we're pressing against. But that isn't necessarily where we should be going. I would say that what we need to be aiming at is this combination, this difficult and complex combination of a fair and livable and viable world. And perhaps part of our task is to understand a livable and viable world as part of that system. So easiest is to push economics. Next easiest is to push social. Environmental we talk about a lot, but actually including it in processes is the task, I would say. But an interesting question. And it's sort of, there's a historical progress there.
It is, thanks. Actually, I think it does very much speak to the core of the range of talks we've had today. I'd be interesting to hear perhaps Hui's perception on this, because I wonder how much of those three aspects depends on the lens that we as individuals and researchers are looking through, in terms of what's achievable and right. So I don't know if Hui, would you like to come in from a perhaps more social perspective on that?
Yeah, thanks. I think it's a very good question and also difficult to answer. For example, for the case of the Red River Delta, it is very difficult for us to meet with the young people because they go elsewhere for a job. So they even, travel to Cambodia or big cities like, Hanoi or Ho Chi Minh City. So they are not around at all. And that leaves all the old people and children behind. So how could we make the living, the Red River Delta, a place that worth living for them to stay, So the most important thing is, how to create jobs for them, so that they could stay in the Delta, especially during the storms or hurricane. I mean, if it hit the Delta, the young people are not around. And in the past, the young people were there, to protect the dike. So if the central dike is broken, I mean, millions of people, will be killed. So, but right now people said, oh, don't worry because we have the mangroves already. I mean, but they cannot just, rely only on the mangroves. I mean, if whatever happens and then the young people are not there. So I agree that, we should go for economics, but these days, many people, including the young people, they realize that if you don't care about the environment, they would not have jobs at all. And then their life would be affected. So, I mean, social and environment would be at the same, same level, but not like a social and environment. So they care a lot about the environment. They care about the water, because of water pollution, they cannot do aquaculture. And then also, it would affect their life because if the water is, polluted, they would be sick, and then they would have to spend a lot of money on the medical bill. So, thank you.
Thanks. I wonder if Salihin or Ryan, do you have anything to add to that? And then, what, in your perspectives, which option is the question was, which is the easiest to aim for, a fair world, a viable world, or a livable world? Perhaps easy is not the right word.
But that's an interesting question. So I think my answer would be, so what is our vision? So where do we want to see us, or or our country, Bangladesh, like 100 years from now or 50 years from now, right? So there has to be a vision. So a world, a livable world, rather. So where do you want to see us, in terms of environmental, environmental settings and also socioeconomic settings. So, and how the interactions or the relationships between different components would function, then. So there has to be some trajectories, some future, pathways. So in alignment with the adaptive delta management principles. So that is what my answer would be. So to answer the other questions that Andy posed there, I can see it. So the question was, in a highly integrated delta SCS, all models stop at the India-Bangladesh border. So how can we achieve proper management of GBM delta futures? So my answer would be in what I just mentioned. So when we analyze the plausible futures, so we assume a number of climatic and socioeconomic scenarios, so plausible futures in the next 50 to 100 years. So among the socioeconomic scenarios, so there would be a number of transboundary water management scenarios, like the renegotiation of Faraka treaty, the Faraka treaty, or other upstream interventions, and how we are going to deal with the other rivers, so for which we don't still have treaties. So there would be some what we call highly a positive sustainable scenario, or some negatives less sustainable scenarios. So, and that kind of exercise that we have done before with Craig and others. So so in that way, in the meantime, of course, we keep on talking to our co-riparian countries and try to come up with better transboundary water sharing arrangements, right? So there are different opportunities and possibilities that the process continues, right? So I'm also part of the process for the last 3-4 years. So there have been some discussions going on in the last interesting discussions going on in the last few years, so that we can understand about the last the previous question of and this question. So so how do we basically translate these complex model results from biophysical and socioeconomic and behavioral patterns, and how do we effectively communicate to local communities so that they can be empowered as equitable partners in decision making? So all those, larger scale, processes, with the modeling exercises, it would be very difficult. But when we concentrate on livelihood specific or locally led adaptations, it's all about smaller scale processes, the individuals. So we can even phrase it as like participatory modeling. So while we develop the chance modeling, the relationships of different components, how different individuals would behave, respond to different different processes. So if we can do it in a participatory way, so then so I think it will be at some point owned by the people also. So that is also part of our part of our plan. So how we can involve more effectively the local people. So I can see the possibilities which is not there for other kind of modeling exercises.
Yeah, great. Thank you. It's a really interesting discussion. I think that leads on to, as you're saying, that the question about how we deliver the outcomes of these modeling approaches effectively to stakeholders and a range of stakeholders, and how with the wide variety of different types of knowledge and data that we've seen in the presentations today, how do we best deliver that in an effective way to stakeholders to really allow them to synthesize these different types of data, knowledge, and understanding that we're learning from some of the work that Hui's done and the modeling that Hoyang's been doing. But Craig?
Yeah, I mean, and answering a bit of Andy's question around sort of communities, so how do we, not only return information back down to communities, but actually how do we capture their input to these models and these, because the very design of these models and what we model and how we do it has massive bearing on the outcome. And and we need to understand, is it answering questions that communities are asking? So and that's something I think we did with in Bangladesh with Salihin and others. And I think one of the keys to that was, doing a lot of engagement early on before you design your model. What are the questions that are being asked? When I worked in Assam, in India, I worked with communities. You would imagine that flooding was the big issue, and we talked. But when we went with we talked with ministries and agencies. But when we worked with communities, they said no. Model bank erosion, because that is what actually is more damaging to us in the long term. So you learn by going and asking. So one of the things is design your model with inputs from your stakeholders beforehand. Don't turn up with a model and say, how useful is this? And then also, things like weightings of the models can come from stakeholders, inputs and balances. So maximize the potential for their voice to actually influence the design, the running, and the outputs of the model. I think that's a lesson that is very valuable.
Yeah, absolutely. And I wonder, Hoyang, from your experience, I mean, what in terms of the modeling you've been doing, where you've been trying to incorporate all of this different types of ways of doing that, how have you had much engagement with stakeholders in delivering this? How are these new techniques being received by those stakeholders? Does the tools that you're developing help to kind of perhaps address some of those questions?
Oh, sorry, I think I didn't catch you.
I was wondering how the tools that you're developing, like coupling these chance models and agent-based models, does that provide a way to perhaps get a lot more information over to stakeholders, and do the stakeholders understand the quite complex modeling that you're doing in the way that having information delivered separately to them might be easier to understand?
Okay, because we've just finished the development of the framework, and in our case study, we just assume some scenarios that if for example, all the people in the flood warning areas get the flood warning during the flood event, and to see whether it will have some positive impact of the on the damage caused by the flooding, compared with the baseline, we simulate the flood events in reality in the history data. And yes, and I think most of our scenarios are trying to explore the some mitigate flood damage mitigation strategies to minimize the damage caused by the flooding, and these are this could be provided for the stakeholders or the government to consider whether to improve their strategies or flood policies to get a better source. I mean, to get better solution of the protection, flood protection. Yeah, I hope I answer your question.
Great, thank you. There was another question in the Q&A box that I guess can open to anyone that wishes to answer this. Has there been any assessment done on non-economic loss and damage?
Is that question for me or
just general, anyone that wishes to chip in there? Perhaps how we would maybe define non-economic loss, perhaps in terms of cultural or heritage loss rather than economic loss, for example.
Yes, I think, in my opinion, in the damage caused by the flood to human society is difficult to quantify in the chance modeling. That's one of the reasons why the chance models with ABM approaches is difficult to be calibrated and validated. And for some severe floods, we might focus on the number of people injured or killed in the flood event, or sometimes we focus on the number of properties affected by the flood. But if we need to validate the coupled model, we need more specific data like the economic loss or something like that to calibrate the model. Yeah.
I mean, we might part of the process we were talking about, I was mentioning about the capitals is exactly this, is trying to understand impacts that go beyond perhaps the physical and financial capitals. So social capital, what is lost during flooding? Well, you lose a huge amount of social fabric. People are moved from their base, they're separated out, they can no longer meet, people migrate away. So there are huge social consequences, both in the short term and in the longer term of flood. There's very large, obviously, natural capital impacts. There are obvious economic ones to livelihoods, but people will lose, for example, burial sites, which can be extremely important culturally to many people. Many people won't, a sense of place can be lost through a loss of environment, sacred places where weddings happening, aesthetics. So people's sense of place is a complex thing and defies what economists might call rational approaches. Why are people not leaving? well, they're leaving because their ancestors lived there. This is where they were born. I've heard many people in communities tell me, I was born here, I will die here. And that defies the economic anticipation sometimes. So there are losses in that. And then human capital, people are no longer educated. Interestingly, when we took a group of Bangladeshi ministry staff who are all engineers into the field to talk with communities, because they'd not gone into the field to actually talk to communities. One of the biggest things that the women said there is, during floods, we cannot get our children to school and they can't matriculate and therefore they can't get a job. Could you change the date of the exams to not coincide with the main floods? And this was a revelation to the sort of members of the government, decision makers, because they'd only thought in terms of impact on livelihoods, engineering principles and flooding. So there's a great deal of social and economic, social cultural context, which is not, it's a good question, that are non-economic in the traditional sense, that have huge impacts on people's capacities. And that's a very large field, and we should take account of that.
That's really good to highlight this. Yeah, Hui, I was wondering if you'd...
Yeah, well, I would like to add to Craig, for example, like in the case of Vietnam, if the forest is gone, that part of their culture is gone too, because normally the women take their daughters, to the forest to show the medicinal plants and to cure what kind of, disease or illness, But if the forest, is gone, and then that part of their culture is gone too. So once we did research with the local women, and then we asked about that, and then it's so hard for them to quantify, the monetary values, how much money that they have lost. But they could just tell us that it would take them a long time to recover the loss. I mean, the loss, for example, like a medicinal plants, and if they don't have the medicinal plants in the forest, they have to go and buy, Western medicine from the shop, and that would cost them, a fortune. And also, when we asked about them what they would need, and they said that we would learn how to swim. Very simple, because the women there, they don't know how to swim, and when the floods, occur, they cannot survive. I mean, if the level of water is too high, and they cannot survive in that kind of circumstance. Thank you.
Yeah, Salahin, please.
Yeah, I'll echo what Craig said. So there are such certain aspects of non-economic loss that directly we don't capture with all these models and setups. But so there are some examples of exercises where, for example, the use of agent-based model to basically examine the migration processes. So just the other day I attended one webinar, so where there was a wonderful presentation. So how this kind of tools can be used to explain certain types of behavior, different people's moving to different destinations, different distances for different periods of time. So there are ways, so there are some examples, but not all of them can be captured. For example, the psychosocial, stresses or impacts that people, experience. So how you, so when it comes to recovery, flood or, other disaster recovery, so many times we mostly focus on loss and damage. So how we can bring back the system to its previous state, just to face the next, disaster event. But for example, the loss of trees, so which provide regulating services. So very rarely, so we consider those, in our assessments. So in some, so we need to do perhaps a better job. So, and going back to the other question about the stakeholder, understanding of the modeling exercise, for example, like the ABM example that was presented today. So there are some, examples in Bangladesh where we developed, with the stakeholders, the warning system. So how we can translate the flood warnings into meaningful messages, and then using it, a different number of flags with different colors. So how we can provide, some improved warning, and accordingly people can take, measures. So both in as anticipatory actions, and also, response, and then followed by recovery. So that kind of, a framework can be developed in conjunction with the stakeholders, and in the end, so it's the stakeholders who would own the framework, own the system.
Yeah, it's fascinating. I wonder, perhaps as a final point, thinking to the future of what these tools might develop into, and how perhaps we might start to include some of these non-economic aspects into these modeling tools, which from what we've seen, aside from being hazard driven, tend to kind of result in economic estimations of loss in terms of an output. I mean, what are the barriers at the moment, do the panel think, to incorporating some of this more non-economic aspect into the tools that we use? Yeah, Craig. You're muted, Craig. Sorry.
My space bar wasn't working. It's a really good question, and one I've discussed a lot. I think it comes down to physics, as in, not that it's easy to do hazard, but it is doable in a kind of, if we persevere, we will learn. To understand social context is immensely complex. It is a wicked problem in its own right. So, I mean, the simple underpinnings of the things that when we're doing risk assessment, so we do, people with the environment, and then go into this sensitivity, adaptive capacity, the social context, capital, social, how people behave, as Salahim was talking about, is data. How do we, we can do qualitative approaches, and we do that and we verify, but you're never going to sample. Well, we've done some huge surveys to try to get that, but they cost millions of pounds. And we have done that. But it's trying to model, in the broadest sense, people's behavior and instincts, and behavior in terms of the depth of, and also understanding that communities are highly diverse. There are many different strategies, many different people, many different motivations. I think we just have to invest hard in the level of understanding needed to answer policy relevant questions, to be pragmatic. So we ask, what are the questions that are being asked? What is going to happen with the Delta Plan 2100? What do we need to know? Right. What information do we need to understand in depth about all of these capitals and the likelihood of behavior? I think we just have to invest the same sort of effort we are putting into hazard. And I think that hasn't happened yet. It's happening, but it needs to happen much more.
No, thank you. I'm conscious of time, that we're coming to the end of the session. So does anyone have any quick riposte to that? Yeah, as a final thought.
Because I'm not an economist, and then I'm a social scientist. So I was wondering, because modeling sometimes is too complicated, and then it's too technical for policymakers. I mean, they are lay people just like me. So I was wondering, how could you tell a story out of your model? Because when you come in and talk with your policymakers, you cannot show, your model, which is too complicated for them to understand. So how can you just, make out of the story, make a story out of that modeling, and tell lay people like us about what it means, and how they could understand your model right away. Thank you.
Yeah, does anyone wish to come back on that?
Yeah, basically I wanted to say the same thing. So being, I used to be a hardcore, modeler, but I went through a transformation process, right? So I'm more into how I can translate, what the model tell me in meaningful languages. So basically, trying to create stories, out of the outputs of the model, and try to come up with, useful narratives. So many of the narratives, I think, I don't agree with many of the narratives that are floating around in the policy arena in Bangladesh. So because some of I really don't agree with, and I try to convey my opinion on that. So so how we can translate all these outputs from model exercises, keeping in mind that not all model outputs are reliable. So there is a huge amount of uncertainty, but now how we can translate those in meaningful narratives, so that would be useful for the policymakers. I think that is what my goal is, at least, so that I can tell you.
And scenarios can help with that, developing
Absolutely
plausible scenarios of futures in the
Absolutely.
language of policymakers or stakeholders or community, whatever their language is, describing, even drawing. We sometimes draw landscapes and say, this is what it might look like. That scenarios and these narratives are really quite important.
No, absolutely. And I think this is a topic on which we could potentially keep going and going and going. And the colleagues on these large projects and in the hub have certainly been having these conversations for longer time than we have today. So conscious of time, and I'd just like to kind of wrap up there. So thank you all very much to our panelists for taking part and for your presentations today. And thank you to those attendees who have come and listened to the talks and contributed to the questions, and hopefully learned something and perhaps been exposed to a few more ideas. Just to finish, I'll just share this and say that again, thank you very much. And if you'd like to know more about the work at the Living Deltas Hub, then please do sign up to our newsletter. There's lots of information about the research that's going on and also the other events that are being organised as part of the hub. So please do sign up to that. But once again, thank you all for taking part, and I hope everyone enjoys the rest of the day, however long in the day you have, depending on whereabouts in the world we all are.
Thank you. That was great. Thank you very much, Chris, and well done, Holly, as well.
Thank you.
Thank you, Chris.
Thanks,
Thank you,
everyone.
Chris.
Bye,
And
everyone.
the organizer.
Thank you.
Bye.